So today I'm going to do a question 110 on LeetCode. It's called balanced binary tree. So the difficulty of this problem is easy, and it has about 1659 likes at this moment. So it seems like it's a good question, and it's only have like a thumb downs of 143. Let me go ahead and read the question. Given a binary tree, determine if its height balanced. For this problem, a height balanced binary tree is defined as a binary tree in which the left and right subtree of every node differ in height by no more than 1. And they give some example. So here is 3, 9, 20, 10, up. And the input for this problem is head, call it root. So like during the real interview, what I want to do is I want to ask some question, like to clarify the definition of height balanced binary tree. So in here, height balanced binary tree, it's clearly defined that there's a binary tree in which left and right subtree of every node differ in height by no more than 1. Yeah, it's still not clear. So one way of like to clarify is by giving an example. So like for this example is we want to turn true, and the other example that they gave is 1, 2, 3, 4, and 4. And for this one, we want to return false. Let me read the definition one more time. A height balanced binary tree is a binary tree in which the left, and the right subtree of every node differ in height by no more than 1. I mean, we can do like some investigation. So if we look at the level, let me Google what's the difference between like height and level. What is the difference between height and level of a tree? I read this answer from I'm reading this answer from Quora. Height of a tree, the length of path from the root to the deepest node in the tree. Level, the number of parent nodes corresponding to a given node of the tree. For example, the root having no parent is at level 0. For binary tree, height of a node is, so it seems like the length of the path from the root to the deepest node. Oh, like the height is like this thing, level. Oh, the height is, so there's only one height, but there could be like a multiple level. So normally we talk about height. When we talk about height, we refer to a tree. When we're talking about level, we refer to a node. Yeah. So this would be level 0, level 1, level 2, level 3. I think the problem with this is right here, because like this have a height of 0 and this is have like a height of 3. And for this one, so if you look at the subtree and the subtree have a height of 0 and this is have a height of 1. Go 1 down. So I think in order to solve this problem, let's see. I think we need to find some sort of way like to passing like a value to the children to let them know like what is the level they are. So we start at 0 and then we pass 1 and pass 1. I think. And then we pass another 2, 2. And then right here we pass 3 and 3. And so once it hit a one is hit a none, we want to return it back. So in this case, it's getting 3. So since they are both 3, so this level is okay. So we can like check that level. And then we pass back. And then I think we want also, since we got 3 here, we want to update 3 to here. So we return is 3 and 2. So since it's 3 and 2, there's only like 1 difference. So this is also true as well. So and then this, however, this get return 3. And then this get return 1s because it hits none. So 3 and 1, there's like 2 difference. They are like 2 difference. So that's why we want to return false. Yeah, same concept. So the idea is we want to pass a number that determine the level of the node. I think this is like my thought process. So pass 1, pass 2, pass 2. Since it hit none, it want to go back or return. Hit none or return. And then so this we get like 2 and 2, so there's no height difference. So we want to return true and return 2 to up here. Up here we do 1 and 2. So since there's only 1 difference in level, we also want to return true. This is like some sort of like recursion. What if we have like something like right here? If this is the case, this would be 3, so this get returned up here. So like this part is like none. But it's also like passed by 3. I think if it's both none, I want to subtract this. Because like when we go from 7 to 10, we increment by 3. But on the left hand side, we hit a none, so we want to subtract it to 2. So right here, we will get something like 2 and 3. So since it's only 1 difference, we pass true. Back to here, we want to pass the maximum value, so it's going to be 3, and over here is 2 and 3, so it's still like 1 difference, so it's okay. And then it passed the maximum to here, so, and then we have like 1 and 3. That's like where the problem is. Yeah, I think I got like a basic concept of how to do this. So how do we code this? So the idea is basically we need some sort of recursions, and recursion, when it return, it need to return what if we have like something like this. So for this case, this would be 4, right? So this would be 3, so it will return 4 up here, and this will be 2, so it will return false back to here. So can return false up to here too. Yeah, but we want to have like a consistent return type, so we cannot just return the number, because like at the end we want to return true or false back to the caller, which is the main function. So my thought process is we can return like a tuple of this. Okay, so here's my thought process. So my thought process is we start with define solution, and then we have root right here. So first thing first, we just want to make sure root is not none. If root is none, return true, none, because it's, I don't know, it's like this would be like a good question, like what do you want me to return if the node is none? Like true, assuming the interviewer said yes, true is when root is none, return true. And then we want to have like some sort of helper. And there's like this helper function is basically the recursions. So in our recursions, we want to use nodes. Yeah, basically just node. And right here, you want to call it in the main function. You want to save it with a temporary variable. Oh, how do I pass the value? Yeah, I need to pass a value. Level 1. This is why level 1. So in the case that the node is none, so it's like this case. So if node is none, what do I want to do? If the node is none, I want to return return true, because when we find a none, it's not necessary that it is false. So and just level -1. And like for this case, we want to, so if so, and then we want to figure out like what does the left return. So the idea is we want to compare these two nodes, right? So my thought process is I would just do left is equal to helper, and then we do like node dot left, and then level plus 1, and then on the other side it basically right and helper node dot right levels plus 1. And I'm making a, according to my logics right here, I assume that I'm going to get a tuple that that's in term of a boolean and then a level, which is an integer, and n. This is a boolean, true or false. So when I get those, I want to return so I want to check the value of the level. So if left, so it would be there index 1, if s minus right 1 is less than 0, no, less than or equal to 1, you want to return true. So basically you want to return true, and then here is basically just the maximum of left, because we said right here, right, when we return, so like up here we want to return the maximum between the two childs. So left, no, yeah, so left 0 and right 0, else returns I don't think this is like necessary, because like at the top the call stack, it will use like this value to compute, and it will figure out that it's false. Like if for some reason that some of the sub tree like down here violated the balanced binary tree down here, it would return false, but the value, like the level of those subtree, will also affect like the top stack as well. All right, let's think about it a little bit. So in the case of, we have 1, 2, 2, just do something simple like this. So in this case, so we start like on top. So root is right here. So root is basically not none, it's a node, and then we call helper. Right here, so right here, this is our root, which is 1, and root is not, node is not none, so it's called left. So it's traversed through left, which is this node, and this node right here 2, so 2 is not none. Now it call again, so like from 1 to 2 it pass. Interesting. I think I don't need 1, I just need 0, because right here when the root, when we get like when we get called by the main stack, the main function, which is the solution, right here level is 0, right? And then right here we add 1, so we pass 1 to node 2, telling that you are on level 2. Oh, level 1. And then it's like node 2 come here, and then we call left again, and then it pass 2 to node dot left right here. And then so 3 is not none, so it call left again, and it pass 3. And what else? And then yeah, so right now 3, right? So 3 is not none, so and then try to call left, so left is none, so let's go up here. So the level like right here, it pass 4. However, since it's none, it's going to return just 4 minus 1, which is 3, so it return back like true and 3 back. And over here, like it's called right, and then so this is like 4. So right here, the right node right here, which is none, it go up here. It's going to subtract 4 minus 1, so it's going to return true, and then 3. So like on this level, on this stack level, we compare the difference between 3 and 3, which is 0, so 0 is less than this, so we return true and the maximum value of the level of the 2 child. So like those, it's going to return true, and the maximum between 3 and 3 is just 3. Now we are on this like stack frame, and then I try to call right. When I try to call right, it pass so this would be the child, so it's past 3. However, that this node is just like none, so it's return level minus 1, which is 2, back to this. So over here it return true, and then 2. So on this stack frame, still the stack frame, left 1 minus right 1. So basically the difference between 3 and 2 is 1, so 1 is equal to 1, so it's returned true, and the maximum between 3 and 2, so it returned true, and then the maximum of 3 and 2 is 3. And then now we are on like the root stack frame. So the root stack frame has been called like all left, and still need to call right. So for right it's 2, Alright, so 2 it's not none, and the level that I get is just like 1, right? And then I call left, it's all none, it's all none as well. So since they are like none, it will return back true and 0, and this will return back true and 0 as well. And then I compare the level 0 and 0, which is less than 1, so it's going to return return what? It's going to return true and 0. Oh, I think I skipped this. There's like a right child right here too, but since this is none, it's going to return just like right here. It's going to return true and 2. It's so, and it's going to return 3 to the 1 here, because you consider 2 and 3 right here. So it's like, since it's just only 1 level difference, so it's going to return 3 and 3. So like on the root stack frame, we compare 3 and 0. So we compare 3 0, there's like 3 difference, so it will return false. And right here we will return 0. So stack frame will return false and 3 to the top. So I guess that works with this example. Let me go ahead and write this code and see if my thought process is correct or not. Alright, thank you for watching. Bye.